Alright, here we go. Here we go. Today, I'm going to work on my old project called pixv. Right? Basically, it just takes a raster image, like any PNG JPEG, and converts it to SVG. And like, it's not vectorizes the shape, it basically just makes pixels in SVG format, right? Why is it usable? Why is it useful? So basically it's made for pixel art, right? So when you do pixel arts, they are like ridiculously small, because every pixel, like, they have really small resolution, and a lot of web applications, when you post these pixel arts, they try to upscale it with interpolation, because of that art becomes really blurry. The easy fix to that is to like intentionally increase the resolution, so every pixel is consistent of like 5x5 pixels, right? But it will also increase the size of the image and feels kinda like a hack, you know? And with SVG you can just scale it to any size and it's always gonna be crisp, right? Yeah, however, it's an old project, and I don't really like the code inside. In Uvium right now, what I have here is rewritten code, but it was rewritten by Gemini, right? So now I'm gonna review it. I'm gonna fix what I don't like. Also, I want to update pass method, right? Because I feel like it can be better. So let's start. First of all, it changed the layout, so it's no longer like it's library first. Now CLI is in a separate directory, and all the functionality is in a root. Let's start with pixv. Method defines the vectorization algorithm to use. Okay, so it's basically an enum. Okay, best rectangle square. Its value checks if the method is recognized value. Okay, I mean, okay, it's a dirty hack because Golang don't have like native enums. I mean, yeah, okay, good enough. Ocean configures the vectorization process. Should I want music to be a bit quieter? Oceans configures the vectorization process. Method scale, okay. Should I call it config? Not sure. Vectorize converts a raster image into an SVG string using the specified options. It is main entry point for the pixv library. Yep. Yeah, okay. Context. Where do I use it? Oh, is it because of goroutines? Image options. Option scale less equals than 0. Scale must be positive. Yeah. But like, what's the problem of making it int? Right? Oh, because I'll have to convert it every time. Okay. Okay, I can live with that. Image data. New image data. Let's check it out. Image data holds a preprocessed, optimized representation of an image for fast, concurrent access. Pixels. Bounds. Visited. Use for atomic operations. 0 false, 1 true. Okay, interesting. Okay. New image data creates a new image data object from a standard image. .image. It iterates over the image once to convert pixels to a flat slice for performance. If I'm not mistaken, there is something similar built-in image package, right? Where calling, like, getting the pixels has minimal overhead. But okay, I mean, it's not bad. Use Int32 for atomic operations. What does it mean? Like, I mean, I said atomic operations which are like concurrently safe, but zero false, one true. Is it like big map, but why is it sliced then? It's weird. For loop can be modernized. Oh yeah, actually yeah. Expected boolean or range expression. Int range. Bounce, image bounce, with height, yep, pixels. Actually, why is it? Wait, with height. Oh, it's temporal variables, yeah. Pixels make color RGBA with height, yep. We're going through everything. This RGBA model directory is fast. Color RGBA model convert. Why is there no documentation? Model can convert any color to one from its own color model. The conversion may be lossy. Okay, interesting. Image add, X bounce, yeah. Color RGB, okay. Okay, so far it makes sense. This RGB model directory is fast, okay. Image data, It returns the color of the pixel at XY. If image PT, what is PT? Shortcut for point. Wait. Oh, I see. So it's just a function. Point. It's kind of weird. Like. Okay, anyway. In bounds. Return color GBA, transparent black for out of bounds. But maybe, just maybe, I should return an error. Or return a new pointer. Okay, returning a pointer is not a good thing. I can also return boolean, right? I can return several values from functions in Golang. Okay, we got add, bounce, return bounce. That's really weird. Why? Bounce returns the image dimensions. But why I can't just make it global? In the sense that I can change it, but does it matter? Add bounce is visited. Is visit checks if the pixel at X has been visited. Atomic load. Atomically loads address considering using the more ergonomic and less error prone instead. Wait. Go no escape. Wait, is it built in? Why there is nobody? Is it... Wait. That's kinda weird. Atomically loads address. Consider using the more ergonomic and less error prone int32.load. How? Where do I get int32? Image data. Int. Is it like int32 load? More copy struct, yeah. Load. Wait. Wait. Your int store. Automatically store value into X. Load your int. Wait, that's so weird. X.v value. Store. Wow. Okay, I don't really understand what the hell is that. Is physics check 6? Yep. Okay, we get D visited. We got the pixel. The pointer. Load it. Check if it equals 1. That definitely has something to do with concurrency, I'm pretty sure. Visit marks. Pixel. Okay, it's visited. Returns true if it was successfully marked. Oh, it wasn't visited before. I mean... Okay. Visit rectangle. Marks a rectangular area is visited. Okay. So we get image data, with height, opt scale. Okay, makes sense, I guess. Places by color. Map color. Screen. Yeah, that's what I've been doing previously. So basically, I segment colors in groups, so then you can draw all the colors in one pass. And as a result, switches take less space. Error switch method. Yep. Here. Yeah, and pass is not multi-threaded because of that it has no context. Default unknown vectorization method. Good. Build SVG. Okay, I'm more curious about build SVG right now because it's something it has written completely from scratch. Build SVG constructs the final SVG string from the generated pass data. With height passes by color. What is it like? Is it SVG like string? So it's basically a pass from SVG, right? That would be reasonable. SVG strings builder, right? Okay, so some metadata with height, XMLNS. I have no idea what's that. Shape render increase of edges. Yep, with height. Sort colors to ensure deterministic output. Great, actually great. Colors. Okay. Range, pass colors append. Wait. That's kind of weird. Oh, so we get colors. We sorting them. Okay. Then we just go in through colors and we get them from the map. Yep. Makes sense. If land equals 0, continue. But what about like, comma okay? Like, okay. And then if not okay. Actually, it has different approach, right? It would not work the same way. There's nothing more to it. Right string, pass fill. If alpha less than 255, fill opacity. Okay, great. Great. Right string, pass. Join right string, yep. Switchy. Good, 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 good. The hex. Okay. Like it. Let's go to square. Square method. Pixel job struct point color. Feels like overkill for me. Don't know. Vectorize square. Context, data, scale. Return map or error. Bounce pixels by color. Make map. Okay. Image point. So it returns a slice of pixels. Mutex. Jobs, make, channel, void group. Worker pool. Actually, I don't need this comment. New workers. Runtime, num CPU. Yep. Group add num workers. For I equals range. Equate not used I. Oh. Okay, we are launching a routine. Then we defer work group done. Is it work? What's it called? What VG stands for? Wait group, wait group. Okay. Local pixels, local pixels. Pixels by color, what's the difference? They're the same. Yeah, and we just append them later. Okay. Oh yeah, that's because they're going in strips, right? And they have, yeah, they have to have separate maps. Okay. Range jobs. Here it is. For X, range. Going through the X, C equals data at XY. Why am I going through jobs? Oh yeah. So because it's strips, like we take only when we have free worker right now. But where do we assign it? Like we created a channel, we created work group, we added num workers, right? Oh, here we go. Yeah. It's kind of confusing that it's at the end, but I guess that's how it should be. That you firstly you consume and then you send it to the channel. Skip transparent pixels. Makes sense. Get data. If it's transparent, continue. I can do it that way in Go, right? Like that. No, I can't. And I can do it that way either. No, I can't. Okay, local pixels, append, local pixels, C. Okay, makes sense. Rush local resource into the main, yep. Okay, mutex lock. Go into local pixels. Pixel by color. Okay, actually it doesn't look efficient. Not gonna lie. I feel like not concurrent approach may be faster. Because there are like so many maps we are going through these maps, we are parsing them in other maps, they are like constant map success, and it just feels, I don't know, kinda bad. Maybe on large image it would benefit it, but I'm not sure if it's how it should be. Okay, points. Okay, index unlock. Okay. I mean, maybe I should do it that way, just in case. So I know for sure that it is gonna be unlocked. And like, for instance, if I'll change the logic of this loop and if I'll return from it, the mutex is gonna be deadlocked. Hello, Enes. Hello. How are you doing? Sup, XM, I'm in the mood right now. You're in the mood right now? Damn, what's happened? Are you in mood to create another great invention on par with Hello World? Okay. Can be modernized. Let's go. Range. Yeah, like that. So we're going through our strips, right? We're going through rows. Then we're doing select. Context done. What is context? Close jobs. Return nil. Oh, interesting. Yeah, so if it's... Yeah, okay. I mean, I'm not really into the context. I got called a cheater. Well, behind in Rapid. I mean, you're not a cheater, you're a smurf. It's like, it feels the same way, you know? So, it was a pretty fair call, I'm gonna say. Case jobs. Okay, why? Yeah. Makes sense. So it's buffer channel. Is it actually buffer channel? No, it's not. It's not buffered. So there is only one jump can enter it. Yeah, makes sense. Good enough. Yeah, good. It's only closing it. Wait, why we're doing that? Oh, because we will never leave this loop until we're gonna proceed all the yeah, it makes sense. Nice. I told him to check my profile. I mean, I'm technically a cheater. I mean, you're a smurf, you know? Smurf. In online gaming, smurfing refers to a player creating a new account to compete against lower skilled opponents. I mean, it's not like you're creating a new account, you're just playing... what's it called? Variation where you don't have a lot of elo. But on the other side, chess.com should quickly promote you to your elo to address it. Also remember the tips I gave you? You followed the first step very well. What do you mean? First step? What do you mean? Sacrifice the game? Don't care about material? I don't, honestly, like I looked at the video, don't care about material. Have I won that game? Have I won? Have I win? Have I won? Honestly, like I watched these 2 videos you sent me from VT, right? VT Alien. And I don't know, man, like I don't really like them. Like, I don't, they feel hello, like he says nothing about what to do. He says like, don't be afraid to sacrifice your piece if it gives you a long-term advantage. Obviously, if it gives me advantage, I would just sacrifice it. But you have to know that it gives you advantage. The other way around, you just can't sacrifice it, right? You won't sacrifice a piece if you don't know, will it give you advantage or not? And to understand if it will give you advantage, you just have to like be able to calculate everything really far ahead. And to do that, as you know, like the only option I see how to do that is just to play a lot of games. Seriously. Like, I don't see this point of don't be afraid. Obviously, if I get advantage, why would I be afraid to give up my piece, right? It like doesn't make sense to me. Hear me out. To make your brilliance you gotta wish for something. I mean, I don't really care about brilliance. As far as I understand, brilliance are like, they just sacrifices, right? So everything brilliant is just a way to point out that you sacrificed a piece to get an advantage. That's it. But you can like get advantage without sacrificing pieces and still win a game. Like, suck a bishop. Wait. Like if you wish a queen to get into your opponent's castle, sack a bishop. Yeah, I mean, you have to know what you're gonna do long term after that, isn't it? Oh, I bet. That's what I mean. And that's something I struggle with because I just can't. Like, my brain is not trained to draw like chess gameplay so far ahead. Pass by color, make. We're creating another map. We're going through pixels. Pass. So we're basically collecting them, right? Oh, wait. We're making a pass. Okay. Honestly, I'm not a good teacher. Because even I don't know how I play like this. Okay. I just play stuff that seems right. Yes, that's the point. Like, I mean, at least how I see it. Like, there is a reason why chess was the first game where like AI has shown its strength, right? Like chess is when like Transformers become popular, because chess is so pattern game. You have to have an intuition to solve it, right? And like these neural networks, what all they do, they like draw what's it called? They draw connections between patterns, right? So they can extremely good understand patterns and how, and like reason within them. And chess is basically the game about patterns. And I mean, unless I'm missing something, there is no quick way to get really good at patterns, but to play a lot of games. But I might be wrong. Pass by color, make. I'm going through pixels by color. Then points. We're creating pass. We're saving it, return. Yeah, actually looks good. I'm not sure about efficiency, right? It doesn't seem like it definitely gonna be faster. I just watched some VTLN videos and learned to play aggressively. And boom, I'm... Like, what do you mean you learn to play aggressively? That's the most... Like, that's the most... How is it called? Confusing thing for me. Because I just watched the videos you showed me. And he was showing some examples of sacrifice, right? And told like, don't afraid to sacrifice your pieces if it gives you advantage. I mean, obviously, why would I be afraid if I know I sacrifice this piece to get an advantage? The point is, I don't know if I'll get advantage or not, right? Like, he shows, if you sacrifice this piece, you get that, and you can checkmate. And like, nice, how do I, in real game, understand that after doing that, my brain like, immediately will draw this path to victory? How? Like, my brain just can't do it by itself. I thought it's gonna be, you know, like, there is such method to understand when you can like put threads here, like make some, I don't know, attentions on these squares is gonna make games easier, and you will be like, it's gonna be easier to find these passes, right? Well, I don't know about you, but okay. I just played Ballad for a long time. Seriously, I actually hear that like you are learning much more not from playing Ballad but from playing long games, because you like have more time to think through. And the more you think through, the more you remember these patterns, right? And finding good moves just become a reflex for me. Yeah, that's what I meant. It's just an intuition, right? Like with neural networks, it just know the patterns. Same for brilliance. Yeah, that's what I meant. I mean, chess is an interesting game, but I feel like the most efficient way to get good is just to play a lot of games. Literally. Okay, so square is done. I mean, it looks good to me. I would want to add some documentation, right? But I guess it's not something I should do on stream. To do, add doc. Rectangle. Let's go. So basically, there are 3 ways. Do you know what? Have you like saw the beginning of the stream? Do you know what is this? What am I doing? I think bullet might help you. You think so? I mean, I can try. It's not gonna take a lot of time. I played Rapid, like I played bullet and I got 400 elo in a day. I mean, it's because you're good at chess. That's the point. You're just good at chess, you know. Like, listen, you got this intuition of going through like possible moves so far ahead. And after that, like, you've seen the pieces and you know what's gonna be the best move immediately. Your brain just tells you that. I can do that. Because of that, when I'm gonna play ballet, I guarantee you, like, I'll do the most stupid moves. When I'm playing slow, at least I can think it through. I can find the good move. And then, next time, my remember will just learn that it was really good move, and when it will see something similar, it will immediately recall it. That's how I think it should work. I'm not good at chess, I just play aggressively. My opponents fall for it. I don't like... How do you define playing aggressively? Because I don't find your... place, like... I'm not sure. Okay, so... square, basically, it just takes every pixel of the image, and it just draws a square in a CG image, right? So it's ridiculously huge amount, because every pixel will need, like, coordinates of 3 points to draw the pixel. So there is another method called rectangle. What does rectangle do? It's basically goes in strips, right? Okay, so it tries to fit the rectangle, right? So it just goes until it hits the pixel as the colors, and it goes the row down, and that way it tries to like compact the image into rectangles. I have an image for that, like here, right? So here is the square strategy. I should actually call it. Well, why do I wait? I should actually call it square strategy. Yep, square, rectangle, and pass. So let's see. Bounce, regs by color, mutex, weight group, non-workers, none of CPU, yep. Rows per worker. Rows per worker, interesting. Oh, interesting. How is it gonna work? It's not gonna work. You can make it concurrent. Okay, let me tell you one of the most important things to play aggressively. Many pros uses the Almighty, huh? H-pound? Almighty? What is Almighty? I got no idea. Having complete power. Omnipotent. What is omnipotent? A name, a title forgot. Like, you must be a genius to do this stuff. You gotta be 2000 elo chess to move H-pound. I mean, like, okay, I'll move H-pound. He'll move his H-pound. What's next? Nothing. Like, that's it. It's not like I'm playing against 200 elo, right? No, I mean, this coding stuff. Oh, the Almighty? But the H-pound is pretty important. Okay. It's not that difficult. Like, PES algorithm is difficult. It's also rewritten. I'm not sure how, like, I asked AI to try, like, to preserve my logic of the algorithm, right? Here it is. Convert. PES. But it's really not pretty, right? I don't like how it is written. And I asked it to just preserve it so I can tweak it manually, right? How isn't this difficult? You gotta have Magnus IQ to do this stuff. Okay, okay. There is a cool book called Range Why Generalists Thrive, something like that. How Generalists Triumph in a Specialized World, yeah. Great book, insanely great book. Right? It's a great book. Book by David Epstein, I hope I read it right, in which he expands on the points from his, to make a more general argument against over-specialization. In the book, he argues that, actually I want to increase. Where it is? In the book, he argues that range, defined as more diverse experience across multiple fields, is more relevant in today's society than specialization because the weak problems of the modern world require bridging experience and knowledge from multiple fields to foster solutions. So what's the, most important take was from this book? Weak problems. And there is I forget the other name. Not easy, simple problems, I'm not sure. So there are two kind of environments. Weak environments and straightforward environments, you know? And chess is straightforward environment. You have clear idea of what you should do, right? There is a clear goal and a clear way to understand if you're doing it right or not, right? And in such straightforward environments, it's really easy to get good if you just put a lot of time in it. Okay? And because of that, most professional chess players, they're playing from the very childhood because they have, the more time you put in it, the better you become. And there is no shortcut. You just have to invest a lot of time. Right? But at the same time, it's really straightforward. You just sit and play. You just invest the time. On the other hand, weak problems are more weak. Because, if you take something like programming, there is no straightforward solution. There is no straightforward problem by itself, you know? There are so many variables you can't... It's hard to make it into a game, you know? It's hard to say, this is right, this is wrong. And such weak problems, you can just try them more, and get this from, random try experience. Understanding of what you should do. And what is valuable in such environment is your general experience. The more experience you have from other fields, the more you'll be useful in such weak problems. Where are you going with this? You said that you got to have Magnus IQ to do this stuff, but the problem is that Magnus don't have to have high IQ. And I don't have to have high IQ to do what I'm doing, right? Magnus just has invested a lot of time in it, and that's because he's good in it. I'm good at programming just because I'm going in breath. Plus I'm also invested some time in programming, right? About this takes that if Magnus plays chess well, it doesn't mean he has high intelligence, right? And also, it's not I'm telling that Magnus is stupid because he seems like a smart fella, but just to pin it out. He has high IQ. Yeah, it doesn't mean he has no... Okay, wait. My take was not that he is stupid, right? My take was that the fact that he plays chess well doesn't make him smart. There are other factors that contribute to it. Yeah. That's it. I mean, chess is an interesting game. It's I would say it's a point for speculation. This file is a direct port of the original... Oh, it's pass. I need rectangle. Okay, we got what? Worker pool. Let's modernize this loop, right? Delete. Range. If statement can be modernized using min. Oh, I see. Why and why min if it's max? If y and more than bounds? Oh, it's min. Yeah, it's min. Bounds.dy y and. compiler invalid argument, bounce dy value of type int. And so what? Int, call it. No new value, yeah, that way, right. Delete. Okay, good. Actually, you know what? Oh, my bad, I didn't copy it. Paste. Just like that. But still good point. We have Axiom roasting a small chess player before GT6. By the way, what happens if you put print hello world in one of these lines? I mean, it will print hello world. Okay, understand. It's like basically executes it one by one, right? Like, ignore these go functions because they execute this, like, this prefix makes them execute in parallel, but you don't have to know right now that. Generally, like, code just executes line by line, right? Generally, like, most of the time. And it will calculate, print hello world. Your terminal is gonna print hello world, and then it will continue calculating it. So, nothing crucial, you know, it will just print it. Actually, it's a great tool for debugging because like it's called printf debugging. You basically place a lot of printfs in your code, and you just always print the state of your current of your data in any position, and that way you can like trace how your data changed and where the bug can be. Anyway, we're going through workers. I don't really like this roles per worker. What does it mean? Like, it will not work. I feel like it should not work. Do I have an example of that? It's not suitable example. Like, if I'm gonna have rectangle with a height of 5, right? If it's gonna be 5 pixels height. What is the case? Like, could it be that it will just unluckily divide it in two parts, right? So it's gonna divide it in rectangle of 3 pixels and 2 pixels. Just because first worker by default takes, I don't know, like 3 pixels, and other takes another 2 pixels of this rectangle and another pixel for another rectangle. I feel like it will not, like, this algorithm cannot be concurrent. Rows per worker means how many people work per row. See, I'm coding genius. I mean, you're not wrong. It's pretty close. Like, it's basically why they called workers, because they work independently. Okay, rows per worker. We got y start equals I multiplied by rows per worker. Okay, makes sense. Y end. Mean of bounds, y start. Yeah, it's not gonna work. I mean, it will, but it will compromise on the efficiency of compression. You know what I can do? What I can do? Mistyped. I can go here. I can take this code. Hope that it will understand the context. Paste it. As far as I understand, concurrency makes the image compression less efficient. As there is, how do I say it? There is, not the case, a possibility. There is a possibility. How's it called? Roles per worker. That roles per worker will split split the rectangle. Rectangle of same color in several smaller ones. Is it the case? If so, is there a way to avoid it without dropping while keeping code concurrent? Set syncing budget maximum, temperature 0.7. Run. While he's thinking, I'll go to method pass. The file is a direct port of the original passing algorithm provided by the user. The logic has been preserved to ensure correctness while being adapted to the new project structure and the helper types. Okay, that's what I asked for. Data structures from the original implementation. Direction. Yeah, so that's an enum, up, right, down, left, rotated. Damn, I've been writing these methods like a year ago, that's insane. Anyway, you gotta use the H found. That's what I do. When your opponent castles, you gotta push H. You can't, like, okay, I'm going H4. I can't do H5 because, like, and then H. Oh, you mean, yes, that's like the opponent goes H5 and then H6 depending on the position. But what if I can't do H6? What if, like, my pawn is pinned by, like, because there is rook, or I don't know if there is knight or bishop in front of the pawn? It's like, I'm saying this because it's something that happens to me really often. Also, always castle to the opposite side. That's how you can play aggressively. I mean, like, the point is, I cannot castle after him because to the moment, like, it gets to the moment when I'm threaded so hard, I can't not castle. Because I'm gonna be so screwed. I'm like, every of my pieces are gonna be pinned and I'm gonna lose everything. I mean, that's how it feels in a game. Anyway, so rotated. How does it work actually? It looks pretty smart. So we got direction. We just do plus R and modular by 4. Yeah, it's good. It's good. So it just goes in loop, right? So up is 0. Right is 1, down is 2, and left is 3. So if up is 0, we are adding R direction. Yeah, so it's like 1. We are going clockwise. It's gonna be right, and because it is 1, modular 4 is gonna stay 1. But if it's left, we are going clockwise to up, right? But because it's gonna be 5, it's modular 4, it's 0. Oh, it's gonna 3, modular 4 is 0, yeah, and it's gonna be up. Yeah, it's pretty good. I like it. And we can go counterclockwise by just using negative. Oh, we can't use negative because it's your int. I mean, maybe it was intended that way. To make it simple, right? You just have to, if you want to go counterclockwise, you have to use 5, right? No, you have to use 3. And then you go counterclockwise. See, you are still thinking like a defensive player. You shouldn't be afraid of pins. And delay in the castle can't hurt you so much. Also, it might sound like a joke, but you should use quack. Brother, like, I'm sorry to tell you that, but you ain't helping. Like, it feels not. How do I say it? There's no specific instructions, you know? You, like, say, play aggressively. What does play aggressively mean? Like, I got no idea. Like, you say, castle to the opposite side. That means I have to castle after him. That means I should have no threats to my king, right? Because if there gonna be too many threats, I'll just be forced to, like, give up my pieces or just move my queen, my king, and I'll not be able to castle. Rotate. So it's basically the same, but it's modifies, yeah. Damn, it's actually so good. Struct point. XY. Moved n calculates a new point by moving n steps in a direction. This function contained the bug in the previous version. No, it's not. Nah. Don't lie to me. There was no backs. No. I know better. He knows there was a back way. No. Don't tell me that. Convert. No. Move then. Oh. Okay, switch D. Up. Return point. Px, Py minus n. Yeah, right. Yep. Down. Yep. Left. It's identical, wait. Where is the bug? He's baiting me, there was no wait a minute. Wait. This function contains a bug in the previous version corrected line. Guys, am I tripping? Is this the same line? Wait. Guys, am I tripping? It gaslights me. Case left, return point, px minus n, comma, py. Oh, it was, yeah, my bad. It was, I asked it to generate first time it made an error there, then I said like, man, you made an error, and it fixed its error and said that it fixed its error. In previous version it was, he was recalling his version previous. Didn't I send you a few example games? I'm about to go insane. I just lost tonight. So that's your limit. Here we go. I mean, sometimes it happens. Especially when you're like too confident, that often happens. Moved. So it's basically just moved n with 1. Yep, good. Damn, it's such a good code. Like, honestly, I'm proud of myself. I wrote it a year ago, and this like library functionality is so good. P moved. Yep. Line, start, point, len, int. Direction. Yeah, that makes sense. I guess it should make sense. Like, it's just there's a representation of the path in SVG, but in a Go instruction. And L start, moved n, L direction, L len. Okay, yeah, good. Really good. Main entry, point for the path vectorization. Okay. Actually, let's get the code. Excellent question. This gets to the heart of a very common and tricky problem in parallel programming: how to divide work without creating artifacts or inefficiencies at the boundaries. Let's break it down. Is this the case? Does your code split rectangles? You correctly identified a potential pitfall, but your current implementation has cleverly avoided. The answer is no. I like it. He's cleverly avoided it. It's like Gemini itself rolls this code and it feels like yeah, like this. It's basically this. Your current implementation has clearly avoided it. The answer is no, your current code will not split a large rectangle across worker boundaries. Here is why implementation worked correctly. Shared state. All your routines share a single image data instance. Crucially, this means they all share the same visited map slice within the data structure. Can you say to Gemini, explain it like you're talking to a 5-year-old so I can understand it? All your routines share pointer image data instance, crucially within that, yeah. Atomic claiming. The data visit xy function acts as a core synchronization primitive. The first routine that successfully calls visit for the top left pixel of a potential rectangle claims the right to process the entire shape. Wow, okay. Unbounded search. You find rect function is not constrained by the worker's y start and y end boundaries. It searches the entire image bounds to find the largest possible rectangle starting from its given point. Okay. Marking the whole area. After a worker finds large... Okay, so it's a bit more sophisticated than I thought it is. It calls data visit rect, which marks the entire rectangle as visited. Okay. Let's trace an example. Image a large blue rectangle from... Imagine a large blue rectangle from y50 to y150. Worker 1 is assigned... Actually, maybe I should make it bigger. Worker 1 is assigned rows 0, 99. Workers 2 is assigned 199. Yep. Workers 1. Main loop eventually gets to the top left pixel on the blue rectangle. Yep. It calls data visit, which succeeds. It then calls find rect. Oh, I see. I see. This function will expand right and then expand down. It will continue expanding down past row 99. So it basically finds the first point, then it goes diagonally until it finds the right point. And then it just basically marks everything as visited. It's so good. It will continue expanding. Actually, my algorithm was pretty similar, if I'm not mistaken. I remember this, like, writing the logic to go diagonally and then move up or down depending on where you hit, like which boundary you hit. Continue expanding down the row, yeah, because it's looking at the global data bounds, it will correctly identify the full rectangle. Worker 1 then calls data visit rect on entire rectangle, yeah. Later, when worker 2 starts loop at 100, it will eventually encounter pixels from the same blue rectangle. However, when it calls data visit, it will return false because worker 1 has already marked that pixels as visit. Worker 2 will simply skip it. Wow, that's good. That's really good. Okay, and that's for you. Of course, let's explain this with a fun story. Imagine you and your friends are coloring a giant coloring book page. The page is a picture made of big blocks of color. Your job is to find every block of color and draw a perfect rectangle around it. Does it make sense? Ennis? I mean, it should make sense for now, right? Should not be that bad. To go faster, you decide to split the page. You take the top half and your friend takes the bottom half. Okay, makes sense. Your smart question. You think, wait a minute, what is the giant red stripe that goes from the top of the page all the way to the bottom? Oh, there is a red stripe, yeah. Will I draw a box around the top part of the stripe and my friend draw a box around the bottom part? Then we'll have two small red boxes instead of one big one. That's not as good. Makes sense so far, right? This very smart question. The magic rule, this very smart. The magic rule your program uses. Your program is clever. Like literally Gemini, like oops, I want to keep this meme for now. Your program is clever, it gives all your friends one very important magic rule. The first person to fight a chef gets to claim the whole scene. So I mean, it's like, I don't think there any sense to read a future. Do you understand how it works, Ennis? Have you, like, understand the 5-year-old explanation for a 5-year-old? Okay, let's modernize it. Oh, it's pass, I need rectangle. Rows per worker, y end. If y start more than y end, continue. Huh? Oh, wait. But how is it possible? When is it the case? When it's really narrow? Of course not. That's sad. Maybe we should ask it, like, to the person that was never born. Maybe it will, like, simplify even more. I mean, actually it was a great analogy of how it works. Not gonna lie. Okay, I'm gonna, like, go through this code, and I guess that's it for today. All group at 1. Hello, Fares! Hello! Hello! How are you doing, man? How is it going? Okay, work group at... Wait, I still don't understand why there is, like, in which situation this statement will be true. How y'all doing? I'm pretty good, like, I took the old project of mine. Like, basically I'm just preparing my portfolio for getting like, some job requests. How is it called? I can't recall it in English. So there is a project called pixv I wrote a year ago. And it's pretty good, but it has some not pretty good code here and there. Job application, yeah, exactly. So it's a great project, interesting idea, interesting realization. It actually has pretty good realization, but it's not readable, it's not clean, right? And what I decided to do? Well, we are living in AI era, and I can just ask Gemini to, like, preserve the same functionality and improve the code, right? Like, why would I do that manually, right? And it basically did it, but it works partially, and basically I just review its code right now. It's pretty good, but it failed to do one algorithm. So basically, what is this? pixv. pixv is just takes your pixel art, right? It basically takes any raster image, PNG or JPEG, and converts it to SVG. And it not converts it in a sense that it detects the shapes and vectorizes them. It basically just draws a pixels in SVG, right? Why is it useful? Because pixel arts are really small, and like 1 pixel, when you post it somewhere, usually platforms will just scale the image, and browsers have this default behavior that it will interpolate pixels, and because of that your pixel art is gonna be blurry. And with SVGs it's not the case, right? And you can like scale to any amount, and it's gonna be smaller in size and better in resolution. I knocked out, but I'm alive, so I'm good. okay. 1600 EEL sounds better than job application, right? I just lost 4 games in a row. I gotta actually focus on trying to understand this stuff. Yeah, so there is three algorithms. Square, which basically just takes each pixels and like draws it in SVG. Then there is rectangle. Like, this algorithm is extremely fast and it can be concurrent. It can be parallel, actually. Rectangle. It's almost the same, but it tries to find rectangles, right? Which is a lot better. Actually, it's a lot better. And it still can be concurrent. Like, I'm not sure... Like, I'm reading code right now, and I'm not sure if the concurrency that, like, will improve the performance. But yeah. And there is the most complex algorithm I've been writing is PES. It's called PES. The one which code I just... Like, I hate to read, because there are a lot of bad pieces about it. But it's really good. So basically, I'm not sure how this algorithm called. Like, there is an end, right? End, like... Damn, what am I doing? Oh, yeah. End, like, end. Which goes around edges. And it memorizes its edges, and the point it goes to the start, it just save it as a shape. Like, it sounds simple, but I don't know, it's... In my memory, it was a really difficult problem. Like, not really, but there was a lot of pitfalls. Like, I was always breaking something. Yeah, at the end, I made it work, but, like, it has a great efficiency. So, Square has this image, like, 2500 bytes. Rectangle have 1300 bytes, which is, like, insane jump, right? And PES has 1100 bytes. I really like this project, however, I want to make it better, right? To make it clean, and now we're reviewing Gemini code. Didn't you make a rectangle? I saw it one of your shirts. I saw it on one of your shirts, huh? Can you explain it like you're explaining to a 5-year-old? So you have squares, colorful squares, you know? And then there is like an end going on these squares, colorful squares, and it just draws. It has like it has the brush on the right half, you know, and it like goes, and it rotates, and basically it draws like the line with this right brush. And the point, this brush, he touches the start. This brush creates a shape, you know. That's how it works. Yep. That's it from. I mean, he just asked that here. Anyway, why is it red? Okay. So now, also, Faris, you're like, an experienced programmer, right? I have a question for you. How experienced you are with concurrency? You should be pretty experienced, right? You're like Linux kernel developer. XM, we asked for 5-year-old, not 50 years old, senior in design. Okay. I have a question for you. I hope you'll help me. Oh. Brush go brew, I understand. Yeah. So, like, look. There is map. Here is map. Pixels by color. Then we create goroutines. So basically, it's just... so you understand this algorithm, right? Of squares. We are going about square algorithm. It is... Gemini made it concurrent, make it parallel. So it basically... divides the image into strips, into rows, and adds goroutine for each row. It's like, in Go it's goroutines, basically coroutines, right? And the problem is, like coroutines, they require some time to spin up, right? Which means you probably want to give more job to it before, like, instead of creating a lot of coroutines which will do real simple job because it's not gonna be efficient. But let's imagine that the image is really long in width. The point is, pixels by color is a map. Then we go in. Oh, we group the colors into groups. So then we can convert in SVG efficiently because one group can be drawn into a single pass, right? It's gonna take less bytes. So pixels by color is basically a color map where key is a color and value is a slice of points. Which is basically a pixel, right? Then we have jobs, we have local pixels, which is another map, the same map, right? It's not gonna be like huge, I understand, even if we take really long LAN. Then we go through, where it is? Yeah, then we save in everything to this map, then we go in through this map of local pixels, and every group from local pixels we save to pixels by color. And it happens concurrently in several workers, right? And after that we have another map called pass by colors, where we go through each color endpoints in pixels by color, and we save it to passes by color. And this amount of maps accessed concurrently, I don't feel like it's good thing. I feel like maps, they're efficient on the large scale, and I feel like this amount of maps is gonna ruin this concurrency scene, and it's gonna be faster to just go like in a single thread. How are 900 smarter than 1600s? Maybe, just maybe, like that means you're not really 1600. I'm sorry to tell you, man, but just maybe you got smurfed, you know. Not smurfed, but boosted. Shush, I'm 1600. Okay, I'll shut up. Anyway, so what do you think, Faris? I hope I made a great job explaining the code, right? I'm not sure if it's like a lot to comprehend at the same time. I didn't understand shit. Okay. Let me look in. Okay. I guess we should just move on then. I think we should just move on then. Like, I guess it's really speculative question, and I should just create benchmarks and see what's faster. That's gonna be the most efficient way to do it. This is why you should explain it like you explain it to a 5-year-old. You want it to be faster in single-threaded. No, like, it was single-threaded by default. Like my original code, it was single-threaded. The point is, I asked Gemini to make it concurrent when it's gonna benefit the performance. So it made it concurrent. The problem is, because it has, like, there is a map per coroutine. So every coroutine has a huge and efficient part, part of memory. How can I say it? Not part, but like chunk of memory, right? Okay. And every coroutine then has to synchronously put these chunks of memory into the single storage of data. And it feels like it defeats all the purpose of the concurrency. That's what I say. But anyway, like, I'll just do benchmarks later, and I guess... Because I see the reasons why it would be faster and the reasons why it would not. So, let's just move on. Rectangle, let's move to rectangle. So we have Y start. Basically, it finds the first pixel of the different color. Then it finds Y end. Yeah, wait. No, wait. That's not the case. That's not the case. It's... Wait. Y start equals... Yeah. So it's basically how many pixels worker will process. And what will every worker do? It will just find the first pixel of a different color. Then it will just go diagonally until it will hit the boundary, the first boundary, right? The one of the sides. And then we go the side it can go until it hits the second side. And that way you'll find the next, the end point, and you can draw the rectangle. So what we are doing? A for group at 1, yeah. Launch go routine. The for group done, yeah. Local rects. Make. Yep, makes sense. Let's modernize this loop. Range. We're going through all the columns, through all the cells. If error, return. Okay, if we got the context to quit executing, we just quit executing. Attempt to visit a pixel. It is if it's already visited another routine, or this one has already claimed it. Yeah, if it's already visited, we just skip it. Data at xy. Yep, skip transparent pixels, makes sense. Then rectangle find rect. Yeah, that's what I told you. Like, go to definition. What it does? Find rect finds the largest possible rectangle of a given color struct. Yeah, so it basically just goes diagonally until it hits the boundary, and then it goes until it hits another boundary, and it finds rectangle. I only understood brush gober, nothing else. At a buffer channel. I'm afraid to get deadlocked. Like, I'm really not understanding the purpose of buffer. Like, listen, what are buffer channels made for, right? That's, like, really... Like, I read the book about the Go concurrency, and there was a particular case where buffer channel makes sense, but it just doesn't stick to me, right? I feel like it's something I'm really afraid to use because I just don't know where is it usable. Your num workers isn't an int, it's your int probably, isn't it? Wait, it's int, num workers, but why? Why do you ask? Anyway, we're going. Where was rectangle? I was. Wait, where am I? Oh, it's square rectangle. Yeah, we're finding the rectangle. Data visit rect. We mark whole rectangle as visited. I'm not sure how efficient it is actually, but should not be that it should not be that slow, right? It should. I can neglect it. Local rects append. Yeah, and we just save this rectangle. Merge local results into the main map. That's what I thought it is. It's like saves everything into a single map. Mutex lock. I don't like this one. I would make it defer. Mutex unlock. Just to be extra safe. For color rects, range local rects. Yeah, and we just save it to the rects by color. Okay. Wait group wait. If like context is closed, we just close everything. It's usually pass generation. Pace by color. Passes by color. Range rects by color. Pass equals make. Okay, we just creating a rectangle, right? For each rectangle we create a pass. We just save it as a string. And then we just return the slice of strings. Anyway guys, I'm leaving. I got to prove XM wrong by grinding 1.6k rapid in one day. Okay, see ya. Good luck. I believe in you. Yep. And we return it. Fun fact. Yeah, partner makes sense. Okay, it looks good. I really have to create benchmarks. Actually, why would I create benchmarks if I can just ask Gemini to create benchmarks? Damn, like, I really feel like there are a lot of code became boilerplate, you know? I just like the definition of boilerplate has expanded so much, it's just insane. Like benchmark is no longer something I have to write, it's something like I can just generate. And spend my time doing more complex tasks like pass algorithm. But also I feel like if I'll prompt hard, you know, like really hard, I'll be able to force Gemini to create working algorithm of this. Anyway, let's just rewind how I wrote it a year ago. So yeah, we got direction in num, we got rotated, which rotates it basically. Rotate, which modifies the original, like the pointer point struct with x, y, int. Then moved n, which basically moves the pointer and cells in some direction. Then we got moved, which basically moves by 1 point, by 1 cell. Then we got move, which is basically the moved, but also modifies the original, the self, right? Line is the representation of SVG line. So it has start, len, and direction. And it's method online, which calculates from these values the endpoint. Vectorize pass. It gets data and scale. Okay. Bounds, lines by color. The visited grid is now part of the image data struct, so it's shared across all calls and correctly prevents reprocessing pixels. Seriously? Oh yeah, makes sense. Yeah, actually, yeah, I just recalled it. We are going through each pixel. If data is visited, continue. Else we get the pixel. If it's transparent, we skip it. Actually, this pattern has occurred so often, maybe I should encapsulate it. Any shape is found, trace it using the original algorithm. Let's go. Shape lines. Find shape. Data points. Okay. Go to definition. Here we go. Core algorithm ported from original. Find shape. Bounds. This vertices grid is temporary for the current shape, just like in the original. Its size to handle vertex coordinates, which can be one large than pixel. Wait, what? Vertices. This vertices grid is temporary for the current shape. Oh, wait, I guess I know why. No, I don't. Wait, I don't know. I can draw the shape from just vertices. It can be nested shape. Then I cannot draw it. Even if it's not nested, there are probably gonna be some problems with it. This vertices grid is temporary for the current shape. Just like in the original. Or maybe its size to handle vertex coordinates, which can be on one large than pixel coordinates. Which can be one larger than pixel coordinates. Oh, yeah, that makes sense. I recall it, that makes sense. So basically, the problem was there is pixels, but I want to draw the edges of pixels, right? I need edges of them. And because of that, I have to use vertices, which is like one len and height more than the original amount of pixels, right? Yeah, makes sense. Shape color. Data add. Shape pass. Find pass. Damn, actually, when I said it's really bad, it's actually like... Okay, maybe I still have not reached the bad part. Data, image data, and point, and direction. Oh, here it is. I don't like it. Vertices. Pass equals line, and 1, and direction. What is 1? Oh, it's the len. It's the len. Start point, end. Yeah, here we go. This condition is a key to the original agreement correctness and termination. Yeah, and it's so long, and I'm not sure if it's... If pass len pass -1 dot end equals start point, yeah, makes sense. And data at end, if color data at end not equals data at end moved direction rotated left, x. Oh, it's such a hacked code. Like, oh, it's so bad. I recall I was doing that because there was cases when there was 1 pixel narrow like stops. Damn. Like it could. No, it could. Damn, how do I show it? So basically we got some pixels, right? Damn, can I get squares? Oh, that is it. So basically, if it starts here, it goes that way. Actually, I should make an... Yep, like that. If it starts at this point, at this corner, it will go by the edge, and this point it will meet it again, and it will see that the shape is closed. However, there is an emptiness inside, so it has to go all around until it meets in this position, and that's why this if statement is so ridiculous. Okay, actually, I'll leave it for tomorrow. As the code is pretty much good, that's the only one I have to work with. Right? Okay, fine, thank you for coming. I guess Enes is not here. Thank you for coming.